Our next lesson is about solving equations with variables on both sides of the equal sign. So you can see from our first example that you will sometimes get equations that have all sorts of stuff on both sides of the equal sign. For example, in our first one, we have two terms which have variables, the 5x and the 2x. We call these variable terms. And we also have the 13 and the negative 8, which we call constant terms. So in order to solve these, there's a few things you have to do before you can solve it the way that you normally would. So our first goal in order to solve these is to get our constant terms to one side of the equal sign and our variable terms to the other. So you're going to get the variable terms on one side, get your constant terms on the other. And my recommendation for this problem is to start by subtracting the 2x from the 5x. So this is my recommendation. Now, if you don't want to do that, you actually will still have a good chance of getting the same answer. So I would start with the 2x from the 5x. The reason I'm going to do that is so that my variable becomes positive. If you do a different step first, you'll still be fine, but I always think it's better to have positive numbers if you possibly can get them. So I'm going to rewrite this, and we will start. So starting with this, we're going to move 2x over to the other side. When we do that, we get 13 plus 3x equals negative 8. Do not forget to bring down that negative. So the next thing we're going to do is everything that we've done before with two-step equations. We're going to subtract 13 from both sides. When you do that, you get 3x equals negative 21, and your answer is x equals negative 7. Once again, I recommend that you just double check to make sure that your answer is right. You would do that by substituting the negative 7 back in for x. So for the next example, I'd like you to try this one on your own. It's your decision what step you want to do first. There's definitely one that I prefer, but I'll let you try it. So go ahead and pause and give it a try. So my preferred way of solving this is to start by moving over this negative 2x. You add that to both sides. When you do that, you end up getting 8 equals 8w minus 8. The next thing you're going to do is you add 8 to both sides. You get 16 equals 8w. When you divide both sides by 8, you get 2 equals w, or w equals 2. So, as with the previous problem, there are many steps that you can start with. You can move over the 8 on the right-hand side first. You can move over the 6 on the right-hand side first. The main thing is that our goal is to get all of the variables on one side of the equal sign and all of the constant terms on the other. So go ahead and try this next one. I want you to take 1 minute to do this one on your own, so go ahead and pause, give this one a try. So if you work this one out correctly, you should have gotten something a little bit weird. And the weird thing that you would have gotten would be when you try to subtract this, you might have noticed that your 5x's are going to cancel out. On the left-hand side, we know that 5x minus 5x is 0, so you're left with only negative 6. Right-hand side, same thing. You're actually left with only negative 5. Now, here's where things get strange. If you look at this, we ended up with a false statement, because negative 6 is not equal to negative 5. There's no way that can possibly happen. So what we are going to say is that there is no solution. By the way, if you're a little lazy, feel free to write a 0 with a line through it. That is another way to show that there's no solution. So another type of problem, this is another weird one. However, this one is weird for a different reason. So I want you to take 1 minute, give this a try, go ahead and pause. So when you do this, you should find that after you distribute for both of these, you end up getting on the left-hand side, you get 12x plus 8. Right-hand side, you get 12x plus 8. You might have noticed that there's something weird going on already. You can keep on going, and you'll find out that when you keep going, you'll just end up with 8 equals 8. So be careful, though. This is not a no solution. The reason it's not a no solution is because you do have a true statement. 8 equals 8 is definitely true. So we actually have two ways that we can refer to this, and I will accept either answer. The first thing is you can say that this is an identity. So if you get a true statement, it's also called an identity. The other thing you can say is you can say that the answer is all real numbers. What that means is that no matter what number you put in for x, you will always get a true statement. So if you substitute anything for x, you can give that a try. On both sides, if you substitute the same x on both sides, you will get the same exact answer. So it's going to be all real numbers. Those are all the possible values for x. So we're going to go ahead and do one word problem. This one I actually took directly out of the book. It's from page 108, and it's problem number 50. So if you want, you do not need to copy this whole problem down because it's in your textbook. So feel free to skip copying it down. I do, however, want you to write the notes along with it that I do. So the problem is Dan and Sydney are getting high-speed internet access at the same time. Dan's provider charges $60 for installation and $42.95 per month. So what I would do at this point is I would underline all of the stuff for Dan in one color. Oftentimes I even take notes on it just in case, because it'll make it a little bit easier to organize your thoughts. And I'm going to do the same thing with Sydney. So then it says Sydney's provider has free installation and charges $57.95 per month. If you want, you can put $0 for installation, or you could just go straight in the $57.95 per month. So the question is, after how many months will Dan and Sydney have paid the same amount? The key word in that is the word the same. So they want to know after how long are they going to have paid the same amount. When you have two values that you're looking for that you want to be the same, you are going to set those two values equal to each other. So that's a little hint for what's coming up. First thing we're going to do is we are going to define our variable. And you can kind of look at the question at the end of this word problem. Usually with word problems, they'll ask a question and that'll give you a hint as to what your variable is. So this one they say after how many months. That's what we're looking for. So our variable, I'm going to use m, and I'm going to call it the number of months. So the next thing I'm going to do is write my equation. So my equation, as I said before, because we're looking for the same amount, we're going to put an equal sign in the middle. What we're going to do is we're going to put all of the stuff we know we have to do with Dan on one side, and everything that has to do with Sydney is going to go on the other. So for Dan, we know he paid $60 for installation. That's something he's not going to pay every month. He's only going to pay that once. So we're not going to put that with a variable. However, the $42.95, that one is going to be paid every month, so we're going to multiply that by the number of months. For Sydney, there was no money for installation, so we don't need to do anything with that. But we do know that she has to pay $57.95 per month. And since it's per month, you're going to put an m with it. So from there, we will get that equation. So I'd like you to give it a try. See if you can solve this entire equation on your own. Go ahead and pause if you do that, please. So the way that we do this, I'm going to rewrite this to make it easier to look at. The way that we do this is we are going to start by subtracting one of our values so that we get the m's on the same side. So the only thing you can really do is you can only really subtract the $42.95m. If you subtract the $57.95, you're going to end up with a total mess. If you tried that, you would notice that you would get variables and numbers on the same side and a 0 on the other. So just be careful about that. Make sure you're doing the easiest possible thing. We bring down our 60. We get that it equals 15m. From there, the problem just got a lot easier. There's no more decimals, thankfully. You're going to divide both sides by 15. And you end up getting that your m is 4. Make sure that when you do that, you don't just write 4 as your answer, but you write 4 months.